Hey guys, welcome to this video on level 2 algebra, and this video we're going to be covering the roots and solutions. Okay, so let's get into it. Alright, so roots. Roots are the values of x that can satisfy an equation for y equals to 0. So basically, when I say a root, I can say, for example, as x squared plus 4x plus 6 equals to 0. And then the values for x that make y equals 0 would be considered the roots. Okay, so yeah, so let's say x plus 1 times of x minus 2 equals to 0. So therefore the roots of this equation would be x equals to negative 1 and x equals to 2, because these values of x would make y equals to 0 and therefore satisfy the equation. Alright, so in this level 2, there's three main types of equations that it's mainly looked at. So number 1 is the two real roots. So two real values of x satisfy the equation. So basically, there's two possible values for x. For one real value, there's only one real value of x. So only one value of x satisfies the equation. And there could be no real roots. So there could be no value of x that can satisfy the equation. Alright, so a big part of this algebra here is going to be the quadratic formula. So the quadratic formula, the formula to find the root of a quadratic for when y equals to 0 can be modeled by the equation. So we have x equals to negative b plus or minus square root of b squared minus 4ac divided by the 2a. So as you can see here, the plus and the minus, if b squared minus 4ac is a positive number, then there can actually be two different values for x. And basically, we're going to be having a really close look at this b squared minus 4ac, as it's going to be a very important part of whether the how many roots an equation has. Alright, so for example, a quadratic can be written by the equation, so ax squared plus bx plus c equals to 0. So these values of a, b, c can be substituted into the quadratic formula to find the roots. So a would be the number behind the x squared, the coefficient, the b would be the coefficient of x, and c would just be the number that's shifted up or down of the parabola. Alright, some further discussions here. Alright, so as you know, the square root of a negative number is not defined, as there are no real solutions. So for example, if I say square root of negative 16, square root of negative 16 is, you can't actually do that, because if you do negative 4 squared, you actually get 16, and if you do positive 4 squared, you also get positive 16. So as you can see in both of these scenarios, positive or negative, that a square of a number is always positive. So there can actually be no real solutions for a square root of a negative number, so it's undefined. So remember, going back to our quadratic formula, remember we had the square root of b squared minus 4ac. So when you have that, so you can obviously see that when b squared minus 4ac is negative, then the whole equation becomes undefined, and that would mean it has no real roots. Alright, so yeah, as you can see here, so hence when b squared minus 4ac is less than 0, this is undefined and there's zero solutions for x. So this basically occurs when there's a very high values for a and c and low value for b, okay? So for example, a good example would be like 1000 x squared plus of 1x and then plus of 100. So the a and c values are very large and the b value is very small, so therefore that's very likely to have no solutions. Alright, so there's one solution when b squared minus 4ac equals to 0. So remember in the quadratic formula we had the negative b plus or minus. However, if it's, for example, if it's negative b plus or minus 0, negative b plus 0 is still negative b minus 0 is still negative b. So as you can see, if the b squared minus 4ac equals to 0, no matter if you plus or minus the negative b, it will still be the exact same. So therefore, there's only going to be one possible solution, because you'll get the same answer twice. So that's where the one solution will come in play. And there will be two solutions for x when the b squared minus 4ac is greater than 0. So basically, this is where the plus or minus comes in play. So negative b plus or minus of a positive number. It doesn't have to be positive. So plus or minus a number that's not 0. So that will come out to be two different answers. That's where your two different roots will come in play. Alright, so some even more further discussions, and some further examples, and bring up a graph. Alright, so as you can see, this is a graph with no real roots. So how can you tell? So as seen in this picture on the left, the graph does not touch the x-axis, meaning there are no values for x when y equals to 0. So as you can see, the lowest value for x is about 8 or so. That's the lowest value for y. That's the lowest y value. It doesn't touch the x-axis, and therefore there's actually no x values that for when y equals to 0. So when y equals 0, there are no x values. So there are no real roots. Okay, so as we stated in the last slide, this happens when b squared minus 4ac is less than 0. One real root. This is an example of one real root. One real root is when the quadratic touches the x-axis once. This indicates that when y equals to 0, there's one value of x that satisfies the equation. In the picture on the left, as you can see, the quadratic touches the x-axis at one place, which is x equals to 0. So therefore, x equals to 0 is the only root of the equation, because it only touches the x-axis once. So this occurs when b squared minus 4ac equals to 0. Okay, so two real roots. Okay, so as you can see in this picture, the parabola cuts the x-axis twice. Okay, so two real roots occurs when the quadratic touches the x-axis twice. This means that when y equals to 0, there are two x values that satisfy the equation for y. So as you can see, when x equals to about negative 50, and when x equals to around negative around 0. So when x is around 0 and when x is around negative 50, the y value is 0. So the two roots would be approximately 0 and negative 50. That would be the two different roots there. And this, as stated in the last few slides, this occurs when b squared minus 4ac is is more than 0. And that's going to create the positive number. Alright, some key terms used in the exam. So b squared minus 4ac is a very important term in deciding whether a quadratic has 2, 1, or no real roots. Okay, so this is known as a discriminant. So for example, if the exam tells you the discriminant is less than 0, then you immediately know that b squared minus 4ac is less than 0. So basically, discriminant directly corresponds to b squared minus 4ac. And the discriminant symbol is just a triangle, okay? It looks like a triangle that represents the discriminant. Alright, so some key terms used in the exam. So if the exam says if a graph doesn't touch the x-axis, there's no real roots. And because, as I was explaining, if the parabola doesn't touch the x-axis, then when y equals to 0, there's actually no x values that satisfy the equation, so there are no real roots. If it touches the x-axis once, then there's one real root, as we discussed in the previous slides. If it touches the x-axis twice, then there has to be two real roots. Alright, so the next one is when roots are equal. So when the roots are equal, that means that both of the roots will come out to be the exact same number. And if you look closely at the quadratic formula, that means the plus or minus must have no effect. And that can only happen when the discriminant equals to 0. So that's when b squared minus 4ac equals to 0. And that means it must only be one real root, because the two answers are equal, so there's only one real root. Alright, so no one or two solutions, that corresponds to, so basically if a question says, there is one solution, then there's one real root. If the question says there are no real solutions, then there are no real roots. And if the question says there are two solutions, then there are two real roots. Alright, so real and rational. Alright, so the word rational, okay, that basically means that the b squared minus 4ac must come out to be a square number. So for example, a square number would be 64. And if b squared minus 4ac equals to 64, then the root, that means it's real, and that means it's real and rational, okay? Because 64 is a square number, and square root of 64 equals to a whole number, which is 8. Okay, so positive real roots, that means there are two real roots, and both the roots are greater than 0. So that's pretty self-explanatory. There's also negative real roots, so both roots are negative, okay? And you also have the discriminant is greater, smaller than, or equal to, and 0. So basically, if they say the discriminant is greater than 0, that means there are two real roots. If the discriminant is smaller than 0, then there are no real roots. And if the discriminant is equal to 0, then there's one real root. It's just some general terms used in the exam that's pretty common for the examiners to switch it up once in a while. So it's really good idea to learn these off by heart. So whatever the examiners put, you'll know exactly what they're talking about. Alright, so we have some really basic practices here. Alright, so we have 2x squared plus 6x plus up to 9, and we're going to ask how many roots. So once again, we're going to go directly to our discriminant, b squared minus 4ac. So b squared minus 4ac will identify our variables. So b equals to 6, a equals to 2, and c equals to 9. And if you just plug this into your discriminant, you should get your answer as negative 36. Negative 36, that's a negative number, so therefore you cannot square root a negative number, so there are no real roots. Example number 2. 4x squared minus 4x minus the 12, how many roots? And once again, I'm going to identify the variables. B equals to negative 4, a equals to 4, and c equals to negative 12. And we're going to plug that into our quadratic formula. So b squared minus 4ac, that becomes 16, minus, okay, just remember when you're doing b squared minus 4ac, it's a good idea to put the 4ac in brackets, okay? So just to make sure you don't make a mistake, okay? So as you can see, 4 times of negative 4 is negative 16, times by the negative, so okay, so you have, wait, sorry guys, just, alright, so I've actually made a mistake in this slide, I just realized. So 4x squared minus 4, okay, so I just made the exact same mistake I was just talking about. So 4 times of negative 4, that's negative 16. Negative 16 times of negative 12. Negative 16 times negative 12, negative times a negative is a positive. So negative 16 times negative 12, that's negative 16, that's 192. And it's actually 16 minus 192. So that's actually less than 0. So this is wrong. This is actually supposed to say there are no real roots. So my apologies on my behalf for that one. I made a pretty bad mistake there. So just realize it's actually 16 minus 192 equals to 16 minus 192. So it's actually supposed to be negative 176, and that's no real root. So apologies for that once again. Example number 3. So 3x squared minus 6x plus a 3. Identify the variables. B equals to negative 6, a equals to 3, and c equals to 3. And okay, so you know a negative 6 squared is just 36. Negative squared is always a positive. So 36 minus of 4 times of 3 times of 3, and you should get your answer to be 36 minus 36, and that equals to 0. So therefore, it equals to 0, therefore there's only one real root. Alright, so some common questions. A common question will normally give you a quadratic with one variable not given. The question gives you the information about how many roots there are, and you are asked to find the values of the unknown variables given the information. Alright, so for example, a quadratic ax squared plus 6x minus 2 has 2 real solutions. Find the possible values for a. Alright, so with this question, okay, they don't give you the a value, so you have no idea what the a value is, you're trying to find that. And they give you the b and they give you the c value. However, they tell you that it has 2 real solutions, so you can instantly use that to your advantage. So you can instantly state that b squared minus 4ac must be greater than 0. So b squared minus 4ac must be greater than 0. 6 squared is 36. Okay, so minus of 4 times of a we don't know, times the c, which is negative 2, and that's greater than 0. And if you simplify this, you should get 38 plus of the aa is greater than 0. And if you rearrange the equation, you should get 8a is greater than negative 36. And final rearrange, you should show that a must be greater than negative 4.5. So for any value of a is greater than negative 4.5, then there will be 2 real solutions. Any other value for a that's not in the specified range will not give you that 2 real solutions. So for example, if a equals to 10, then there will be 2 real solutions. If a equals to 15, there's 2 real solutions. However, if a equals to negative 6, then there's not 2 real solutions because that doesn't meet the specified range. Alright, so a few simple examples here. So a quadratic negative 3x squared plus of the 6x minus b does not touch the x-axis. find the possible values for b. Alright, so it does not touch the x-axis. The first thing that should come into your mind, there are no real solutions because the graph, there's no real x values for when y equals to 0. So b squared minus 4ac instantly you know must be smaller than 0. Right, so you just substitute your numbers, the variables you do know that's in, and then you substitute your unknown value, which is b. So 6 squared is 36 minus of 4 times of negative 3 times of negative b, and that's less than 0. Alright, so 36 minus 12b is less than 0, and just a few steps of simplifying here, and you should find that your final answer is that b must be greater than 3. So for any value of b greater than 3, then there are no real solutions. And this is proof with the graph. Okay, so this with the graph on the right is when b equals to 4. When b equals to 4, then there are no real solutions. As you can see, the graph does not touch the x-axis. However, when b equals to 2, then there are 2 real solutions because the graph does touch the x-axis twice. So as you can see, this does validate the b must be greater than 3 proof that we just found out. Alright, so example 2. The quadratic 5x squared minus bx plus of 2 has equal roots. Calculate the values of b. Alright, so 2 equal roots, the first thing that should come up to your mind is that there's only one real solution for b. It's not for b, so sorry, there's only one real solution for x. So b squared minus 4ac must be equal to 0. And once again, you can pull out your discriminant. So b squared minus of the 4 times the 5, which a value, which is 5, times the c value, which is 2, equals to 0. And just a bit of simplifying here. So b squared minus 40 equals to 0. B squared equals to, so just be careful. So you should find that your answer is b squared equals to 40. So therefore, square root of 40 must be equal to b. But remember that a negative number squared is a positive, and a positive squared is also a positive. So your b value is actually plus or minus square root of 40, because they both work. As you can see on the right hand side, that's when b equals to negative square root of 40. And as you can see, it touches the x-axis once. And when b equals to positive 40 on the left hand side here, you can see it also touches the x-axis once, just in different locations. But however, it still meets the criteria of equal roots. So therefore, both of these are valid answers. So remember, in the exam, don't forget to leave out the plus or minus, because you could get penalized. Alright, example 3. The quadratic negative 3x squared plus of bx plus of c has two equal roots. Find b in terms of c. Alright, so once again, 2 equal roots. First thing that comes to your mind is b squared minus 4ac equals to 0. Alright, so this time there are 2 variables you don't know. However, you're just going to find b in terms of c. So therefore, you just do what you would normally do. You substitute your numbers into your discriminant. And if you simplify that, you should get that b squared plus of the 12c equals to 0. And once b in terms of c, so it has to be b equals to something, okay? So b squared equals to negative 12c, and therefore b equals to square root of negative 12c. And that will be your final answer. However, there is a part 2 to this question. So explain in terms of the question what you know about value of c. So what you would know about value of the c is, you know there can't be a square root of a negative number, because that will lead to no real roots, okay? So you know that b equals to negative square root of negative 12c. If c was positive, for example, if c was 6, then b would be equal to square root of negative 72, and that'll be wrong. So that means you have to infer that c must be a negative number. So negative times negative is a positive. So c must be a negative number to make the square root a positive, and therefore for you to have the correct requirements, okay? Alright, so what you're going to say is, that means c value must be negative. Yep, just because c was positive, this will make the square root of a negative number, which will result in no real roots. C must be negative to ensure the square root is possible. Yeah, so that'll be your main statement for part 2. Alright, example 4. The quadratic equation x squared plus s plus 2x plus 2s has 2 real solutions. Find the range of values for s. Okay, so you must be seeing, s plus 2x. So don't worry, it's the exact same process, okay? So s plus 2 of x, so that's basically your b value, would just be equal to s plus 2, okay? It doesn't really change much, okay? So b equals to s plus 2, basically. Alright, so once again, two real solutions. B squared minus 4ac is greater than 0. So you're going to be plugging in all the variables you know. So a equals to 1, b equals to s plus 2, and c equals to 2s. Okay, so if you plug these numbers in, you have s plus 2 squared minus 4 times 1 times 2s, which is greater than 0. And it just comes down to really simplifying. Okay, just make sure you don't make any silly mistakes during the simplifying process, and you should be fine. So you should simplify to s squared minus 4s minus 4 is greater than 0. And you can just solve for your s values first. So plug into your quadratic, not quadratic, plug it into your graphics calculator and solve for x. So when x equals to 4.83 or x equals to negative 0.83, y equals 0. So these two values of x will be your roots. However, we want to find the range of values for s for when it has two real solutions. Alright, so you have to infer here that so first thing you have to infer here, the easy way to do this is that you know that it has to be a positive parabola. This is a positive parabola because a is more than 0. So the s squared is positive. For example, if I had negative 2s squared, for example, if I had negative 2s squared, then the a value would be negative. So therefore, this would be a negative parabola. However, in this case, it's more than 0, so therefore it's a positive parabola. So you can roughly sketch out on your exam paper, you can slightly sketch out a positive parabola shape. So that would be a positive parabola shape. And as you can see, you want to find when s squared minus 4s minus 4 is greater than 0. As you can see, the graph is above the x-axis when it is to the right of one root or to the left of one root, okay? So basically, when x is less than negative 0.83 or x is greater than 4.83, that's when you will have your positive, that's when your equation will be true. So that will be your range of values. Alright, so that will be your answer here. So as seen in the graph, okay, I did make a slight mistake here. So instead of x, just write s. Okay, so supposed to be s is greater than 4.83 and s is less than negative 0.83. My apologies there. Alright, example 5. The equation gx squared minus g plus 3x plus 3 has two real positive roots. Find the values for m and the roots. Not m, what the heck am I doing? Find the values for g and the roots, okay? Alright. So two real positive, that means b squared minus 4ac. Both roots must be greater than 0. Okay, so those are the two requirements there. So b squared minus 4ac is two real positives, so it has to be b squared minus 4ac has to be greater than 0. Alright, so you're going to start by modeling your equation, okay? So g plus 3 squared, okay, so you might notice that b equals to negative g plus 3. However, and once I say a negative number squared is a positive number, so I just ignore the negative, okay, because b squared must be positive. So g plus 3 squared minus, just plug all your variables in, and then simplify. Alright, so once you simplify, you should get g squared minus 6g plus of 9 is greater than 0. So in this case, I'm going to factorize, so therefore g minus 3 squared is greater than 0. Alright, so the thing you can immediately be seeing here is that, remember what I was saying, that any number squared must be positive? That means any value for g will make a positive, because it doesn't matter what g is, it doesn't matter what the number comes out to be, if it's squared, it will be positive. So therefore, your requirements are met. Okay, so as seen in the equation, the discriminant simplifies to g minus 3 whole squared, meaning that since any number squared is positive, this fulfills the two real positive roots. And yeah, and then a second part of this question will be finding the roots, okay? So that will be using our quadratic formula. If you use our quadratic formula, we should be able to find our roots of the equation. So just continue here. So using the quadratic formula to find the roots. Alright, so basically we have g plus of 3 plus or minus square root of g minus 3 squared, whole thing divided by 2g. I know this, the thing on the digital device might not be seen really clear, and I apologize, but just try to make a bit of sense out of it, I guess. So, for example, if we do g plus 3 minus the discriminant, then we should get g plus 3 minus g minus 3 in brackets. So you should be getting that you should be getting that your answer should come out to be 3 over g. So if we simplify that, so g plus 3 minus g minus 3 in brackets. So g minus g is just gone. So g is gone. 3 minus 3, that becomes 6. So 6 over 2g is the same as 3 over g. So that's where your simplified 3 over g will come from. If we do g plus 3 minus, we did the minus. If we do g plus 3 plus of the discriminant, so that becomes g plus 3 plus in brackets g minus 3. And that should give you, so g plus of g, so g and g becomes 2g, and 3 plus of negative 3, those cancel out. So it becomes 2g over 2g, and that simplifies to 1. So your roots of the equation will be 1 and 3 over g. Alright, example 6. The equation 2 times of x plus q divided by z minus x equals to x minus q over z plus of x. Find the roots of the equation in terms of z and q. Alright, for this question, okay, we're gonna the first thing we're gonna do is gonna cross multiply, okay? Because these two are equal, so we're gonna say that the numerator times the denominator of the other side is equal to the denominator of one side times the numerator of the other side. So basically it should be going in diagonals. And then you should find that those two are equal to each other. So basically what I'm trying to say is cross multiply. So the numerator of the first fraction would be 2 times of x plus q. That's the numerator. And this numerator is going to be multiplied by the denominator of the second fraction, which is z plus of x. And that is equal to the denominator of the first fraction, which is z minus x, multiplied by the numerator of the second fraction, which is x minus q. And they're both equal to each other. And then we're just going to make everything equal to 0, and then we can find the roots of the equation. Alright, so first things first, we've got to simplify. So if we simplify, so this is just a basic algebra using a simple expanding in algebra, okay? So just a matter of simplifying the equation. If you simplify, you should get 2x squared plus 2xz plus 2x cubed plus 2zq equals to negative x squared plus xz plus x cubed minus qz. And now we're going to move everything to one side and make equal to 0. So therefore, after we make equal to 0, we can use our quadratic formula in order to find our root in terms of z and q. So by moving everything to one side, I'm going to move everything on the right hand side to the left hand side. So that the negative x squared becomes positive x squared, so everything just flips. So positive xz becomes negative xz, positive x cubed becomes negative x cubed, and negative qz becomes positive qz. And if you simplify this, you should get 3x squared plus zx plus qx plus 3zq equals to 0. And now you can start. So one last step before you use the quadratic formula is to group together. So basically factorize the zx and qx into 1. Okay. So zx and qx, you can take out x as a common factor. If you take out x as a common factor, then you're left with x plus q. So you can say not x plus q, z plus q. So you end up with x. I like you saying x. So you end up with z plus q multiplied by x. Okay. So if we just factorize what's in the middle, so no, apologies guys, the last video got cut off, so I'm just going to leave off where I just left off. So now we have our simplified formula. Okay, so now we're just going to use our quadratic formula in order to find our roots. So we apply our quadratic formula, our negative z minus q. So how do I get negative z minus q? So you know the quadratic formula is negative b plus or minus. So you know that the b value is z plus q. So therefore, negative b would just be negative of z plus q. And that will make everything inside the bracket negative. So negative z minus q. So that's how I got the negative z minus q. Plus or minus z square, square root of z squared plus of 2z cubed plus of q squared. So how do I get that part of the equation? that part of the equation is basically b squared. So b squared would just be z plus q squared, and that's just applying the basic algebra skills to get there. And then we're going to be doing the minus 4ac. A is equal to 3, so it'll be a equals to 3, and then you know our c value equals to 3zq. So it'll just be 4 times square root of z squared minus square root of z squared plus of 2zq plus of q squared minus 4 times 3 times of 3zq. And then finally we're going to be dividing by 2a. Our a value equals to 3, so if we divide by 2a, we'll just get divided by 6 as our answer. So now we just simplify a little bit more. So we just say negative z minus q plus or minus square root of z squared plus of 2zq plus of q squared minus of the 36zq. So that's basically just simplifying the negative 4ac. And then don't forget you divide by 6 at the end. And that's really all you need for this question. You don't actually need to simplify any further with this, and you should be able to get full marks for this question just by leaving it up to here. Alright, thank you for watching this video. I hope you enjoyed, and if you have any questions, leave it down in the comments below, and I hope to see you all in the next one. Thank you, bye.